Let's work on our next speaker. Ryan Lei is currently working as a tech lead and video codec specialist in the Media Foundation core video team at Meta. His focus in algorithm and architecture for optimizing cloud-based video processing, transcoding, and delivery at scale for various Meta products. Ryan is also a co-chair of the AOM testing working group and actively contributing to standardization of AV1 and AVM. Let's welcome him.
Thank you very much for the intro. Hello everyone. Today, I'm going to talk about latest AV2 coding gains with CTC, and at the same time talk about some of the future works. So basically, the testing subgroup was established at the beginning of the AV2 development. So at the beginning, the main responsibility of the testing subgroup is to define the common test conditions, gather all the test sequences, and define the encoding configurations, and implement all the testing script and framework, so we can start to leverage that to evaluate all the coding tool proposals and decide whether we can adopt them or not. So over the past few years, there has been quite many iterations, improvement on the common test condition. So the latest version is CTC v7. Recently, there's also some work to extend the common test condition to cover the extended color format like a 422, 444, which Vibusi is contribute quite a lot in that regard. So as Andrew mentioned, after the common test condition established, testing subgroup conduct regular work for every AVM releases. We basically focus on what is the coding game progress over the past release, and also testing subgroup will also conduct extensive tool on and off tests to understand the contribution of each coding tools. So for today, all the data I'm going to show will be based on the AVM v10 anchor, which was released around June time. And also, as Andrew mentioned, the latest AV1 v11 anchor just released a few weeks ago. We only have some preliminary result. I will show you today, but it's not the full result. So at the same time as we are wrapping up the AV2 development, testing subgroup also start to ramp up to develop the methodology and prepare the test content for a full verification test and also the subjective test. So next I'm going to talk a little bit about the high-level overview of the common test conditions. So first of all, regarding the test sequences, we gathered about the 90 video sequences and 50 images. So the test sequences are classified into different classes. Class A represent all the natural videos ranging from different resolution, 8-bit, 10-bit. And Class B mainly covers all the synthetic content, including gaming, animation, and also screen content. Class F is like static images ranging from HD all the way up to 8K resolution. Class G covers all the HDR content. So also the first time in video coding standard industry development, we introduced the UGC content, which is user-generated content. We want to make sure the test content covers the use cases we are dealing in the production. So regarding encoding configuration, the main requirement for the CTC definition is we want to only focus on the coding gains from the coding tool, normative coding tool proposals. So with that in mind, we disable all the algorithms at the encoder level consider the non-normative, such as two-pass encoding, adaptive QP modulation, and K-frame filter. All those algorithms are considered non-normative. It's encoder specific. Encoding configuration-wise, we cover typical all intro configuration, which encode the frame as intro frame only. and random access configuration, which are the most popular ones for VOD use case. So in the random access configuration, we encode with 2 gobs, closed gob, and the subgob size is 16 frames with 5 hierarchical layers. So we allow the fixed QP offset for frames at a different layer. So on the right-hand side, on the top, you can see the QPs or Q index used for different encoding configuration. On the bottom right-hand side, you can see one example of the QP assignment for the frames at the different hierarchical layers. For example, if a Q index 110, 110 is used, it is typically applied to the frames at the hierarchical level 5. And for frames at other level, you have a fixed QP offset applied to those frames. This offset does not change based on content. So low delay configuration similarly encode all the frames without any future reference frame. Also, in the first time in the coding standard development history, we introduced this adaptive streaming configuration. Again, it's similar, very close to our production use case. In the adaptive streaming configuration, we encode the 4K sequences in the A1 class into 6 resolutions. For each resolution, we encode with 6 QPs. So after decoding, we upscale the lower resolution video back to the original 4K resolution to calculate the quality metrics. So for the downscaling and upscaling, the standard Lanczos 5 filters are used. So on the right-hand side, you can see one example. In order to produce a smooth convex hull, so after we encode for each resolution, get this 6 RD points, we further run some bilinear interpolation to interpolate some points in the middle of those points to create a smooth curve like what you see on the slides. So after we get all these curves for each resolution, then we can calculate the convex hull from this very dense RD graph. So then based on the coding tools, we can produce 2 different convex hulls from the control group or test group. Then we can calculate the BD rate between these 2 convex hulls to indicate the coding gain or loss from particular coding tools. Quality metrics-wise, all the popular metrics used for benchmarking codecs are included, like traditional PSNR, SM, multi-scale SSM, VMAF, and VMAF NAG, which kind of suppress all the coding gains from sharpening or those type of enhancement. And also, all these coding tools are implemented in the VMAF tool. Also, the proposal from Netflix, the Canby coding tools introduced to measure the artifacts from bending, which is also included in all those metrics. Here is some results. As I mentioned, this is mainly based on the V10 anchor. In this full test, in order to fully measure the coding gain, so we disable the tilings, only single tile is used. In all intro configuration, you can see overall we are, in terms of PSNR value, we are seeing about 22% coding gain. And also the VMAF is about 24%. You can see that the class B2, which is screen content, the coding gain is much higher. It's almost 40%. One thing I want to call out is when to calculate the PSNR, BD rate PSNR for value V, we take the PSNR Y and UV plane, we apply this 1411 weighting factor to get the final aggregated PSNR value. On the right-hand side, you can see the progress we made from the beginning of the AV2 development, from like Anchor V2 all the way up to Anchor V10. You can see we're making steady progress in terms of coding gain. This is random access. As I mentioned, this is the most popular use case for VOD. Similarly, you can see that on average, the coding gain in terms of PSNR value V is around 29, almost 30%. VMAF is slightly higher, almost 34%. Again, like screen content is almost 40%. UHD content typically have higher gain than the HD content. Low delay, roughly 25% in terms of PSNR by UV and also VMAF. Adaptive streaming configuration, because the convex code can be constructed with different quality metrics. So as you can see here, the PSNR by UV gain is around 30%. VMAF is 35%. It's slightly higher than the random access configuration. Still image, around 15% for both medium resolution to high resolution. As I mentioned, the V11 anchor just released few weeks ago. We don't have the time to finish all the complete CTC test yet. This is just a preliminary test on the mandatory class, which does not include the HDR and also the UGC content. So when we compare with V10 anchor within the same test configuration, we see about 0.3% gain for the random access configuration and also 0.7% gain on the low delay configuration. As you will see, as we approaching to the end of development cycle, the coding gain will start to plateau, and it's very, very, very challenging to get actual gains. Recently, we also started to extend the common test condition to cover the 422 and 444 content. We gathered quite many test sequences with different resolution, bit depths, and color format. In order to validate if the coding gain for the extended color format is similar as the standard 420. So we also conducted the test, and at the same time we inspect all the code, figure out if there's any implementation issues for those extended color format. So as you can see here, similarly for the all intro random access and low delay configuration, the coding gain for the extended color format is very close to what we see from the standard YUV 420 configuration. As I mentioned, we are starting to prepare the test content for subjective test. The result I'm showing here is one test done by the Google internal teams. It's not done by the testing subgroup. So what Google team did is that they mainly focus on the UHD 4K videos, and then they use this 11-point DCR stand methodology to run the subjective test, mostly with expert within Google. This is the result they got. So overall, for like UHD sequences, they are seeing on average about 38% ish coding gains in terms of video MOS. Again, this is a preliminary test done by Google, only focused on the UHD sequence. So main takeaway is basically, as Andrew mentioned, we are closing to the final stage of AV2 standardization. And so far, the coding gain we are seeing for random access is close to 30%. So we are hoping like the subject test will get a little bit higher than that. We are also kind of working on a very comprehensive verification test against AV1 and start to conduct many subjective tests to validate the coding gains. Yeah, so that's all I want to cover. So please stay tuned for any future updates. Thank you.
We have time for maybe 2 questions from the audience. Yeah, I do have a question about the different use cases: random access, low delay, adaptive streaming. So when you're deciding whether to intake a tool, how do you weight across the multiple use cases, or is there any rule of thumb?
I think at the time when when we evaluate each in-video coding tool, first of all, we evaluate the gain across different configurations. But most of the focus will be on the random access configuration. But at the same time, once we see a coding tool bring gains in random access, typically it will also have some gain in low delay and all intro, even though the gain may be lower. So, but I don't remember seeing anything like we actually cause regression on other configuration. Yeah, we have also at the same time we look at the gains on all different quality metrics, but primarily still focus on the PSNR value. Yeah.
Thank you. Let's thank the speaker again.